In section 4 of chapter 2, we're going to look at dividing polynomials, also the remainder and factor theorems. Let's look at the objectives. Use long division to divide polynomials. Use synthetic division to divide polynomials. Evaluate a polynomial using the remainder theorem. And use the factor theorem to solve polynomial equations. All right, let's get started. Now, this is the protocol for long division. If you'd like to read it, you can, but I will show you how it works as we do it, and you can pause on each of these. And there is a protocol to follow, as I mentioned, and we'll get started on this one here. Now I'm going to use the whiteboard for this. This is example 1. So we want to write it up here. So first of all, we have to put this in descending order. So let's do that together. 2x to the third minus 3x squared minus 11x plus 7. And we're going to divide this by this divisor x minus 3. Okay, I'll go to the whiteboard now. Well, we lost our values here. Let's try it this way. There we go. Okay, let's get rid of this first. Now, there is a protocol, as we mentioned, and we'll go through it step by step. So you're going to take this item, and how many times does this item go into that? And you may not be sure. So a shortcut or a little crutch here, in a sense, is just write this over here and divide by x. So you're simplifying that. Well, that's going to go into this 2x squared times. Put that up there. Now you're going to multiply this x by this, and you should just get that, 2x cubed. Now you're going to multiply this term by that and get a negative 2 times 2 is a negative 6x squared. Now the protocol for this is you draw a line, and now you have to subtract. And in algebra we subtract, I'll change colors, by changing the sign and then adding. So this column just becomes a 0 that we don't write. And when we combine like terms here, we get a positive 3x squared. And we bring down our negative 11x. And we use that same technique. 3x squared divided by x will give us a positive 3x. So now when we multiply this term by this, we get a positive 3x squared. And a negative 3 times this is a negative 9x, keeping our terms in like term columns. Now again, we're going to draw the line. And what does that indicate? That we're going to subtract. How do we subtract in algebra? By changing the signs. So this will become negative, and this will become positive. This then is a 0 that we don't write. And then we add this up, and this is going to be a negative 2x. Now again, we have a negative 2x divided by this x, and that's going to go negative 2 times. So x times negative 2 is a negative 2x. This is what we would expect. Now a negative 3 times a negative 2 is a positive, and we didn't bring this term down, let's bring it down, a positive 6. All right, get carried away here. What do? We change signs. We're subtracting, so this becomes a plus. This is going to be a 0. This becomes a negative, and we end up with a plus 1. So our answer then is this. Now, sometimes they like the word, or they put the remainder, 1 over x minus 3. And I see that some of it was cut off, so here it is in clearer detail. I'll be careful of that in the future. Now, here is the protocol for synthetic division. And if we have our divisor in this form where it's a 1x minus some constant, like so, there is a protocol to do this, and that's what I will show you here as we continue with our slides. But these are the details of it. And pause if you want to read them. Okay, I'm going to set this up on the whiteboard also. And I'm going to be sure it's down so we don't cut anything off. So here we see it now, example 2, using synthetic division. All right, let's go on, and I'll go and review those details, but we'll use the whiteboard. Now, one qualification to use synthetic division is your divisor must be in this form. So it's a 1x. Now, x minus c. What would, if this is it looks like a positive 2 there, what would it be in order to be in that? Well, it would be x minus a minus 2 would give you a positive c here. So the value of this c that we're going to use in synthetic division will always be the opposite sign of this. And more on that a little later. So what's the protocol? Well, we set it up, and instead of using the regular division bar, we're going to use a sort of an upside down division thing here. And what number are we going to put out here? Again, it's just the c value, which we now know is a negative 2. Now, we just want the coefficients of these variables. Now, the coefficient of this, x to the third, is 1, so we put a 1 there. Now, notice there is no x to the second power, so we have to put a 0 there to occupy that x to the second power's position. And then we have a negative 7, and then we have a negative 6. Now, the protocol for doing it is whatever's here, we just take down and put it there. So that's a 1. Now, we take the negative 2 multiplied by the 1 and get a negative 2. Now, we don't change signs, we just add these up. This will be a negative 2. Now, we take our negative 2 and multiply it by this negative 2 and get a positive 4. We add these up now and get a negative 3. We then take our negative 2 and multiply it by negative 3 and get a positive 6. Add these up and we get a 0. So this would be our remainder column, And since it's a 0, it indicates that -2 is actually one of the zeros if we were trying to find the zeros from this quadratic or anyway, the power of 3, the degree 3 of this original equation. Okay. Now, in translating this, since we've taken out one of the x powers already, this is going to be x to the second. This is going to be x. This is going to be without any variable, and our remainder is 0. So the result of this synthetic division then is x squared, we usually don't write the 1, minus 2x minus 3, and there's no remainder. So in a sense, this is one factor, and our original x plus 2 was another factor. And if we wanted to find the zeros of this, relating to what we did earlier, just equal that function to 0. And again, this would be equal to 0. So one of our solutions, our roots, is x equals -2, which we proved by not having a remainder here. Something to keep in mind. Now let's take a look at the whiteboard and see what they have. That's step 1 here. Let's go to the next one. They're showing us that. There's our resulting answer, no remainder. And let's pause. Now, as you do your homework, of course, you'll be practicing this technique. All right, now we're going to take a look at the remainder theorem. That if a polynomial whose function is this is divided by this, then the remainder is this. What happens? Well, let's check it out in the next slide as example 3, using the remainder theorem to evaluate a polynomial function. And suppose we get then, this is our function. We're going to take this theorem, substitute the -4 as our divisor over here, and let's see what we get. And I'll do it on the whiteboard. And there are different ways to do this. Here is one. I like the way I've been showing you, and we'll continue that. Let's go to the whiteboard. So there's our original function. We're now going to take, since it has all the values, we don't have to use any space holders. We're just going to take the coefficients. So 3, 4, -5, and 3. And they're giving us the -4. So we're going to bring the 3 down. A -4 times 3 is a -12. Add these together, you get a -8. -4 times -8 is a +32. Add these up and you get 27. -4 times 27 is a -108. Add these up and you get a 105. So when we have f of a -4 for a function, that's going to equal a -105. Now remember that, and we'll look at it on the regular screen here as well as we clear this up. There's our 105. Now we did this again as using the remainder theorem to evaluate a polynomial function. I'm keeping this same function here, but now I'm using that -4, substituting for an x, and going to the whiteboard, and let's check that out. Here we go. And let's just do this and see what this ends up with. So -4 cubed will be a -64 times 3. A -4 squared is 16. 16 times 4 is 64. This is a plus 20, and this is a plus 3. Now let's see what we get here. I'm going to go back and do the calculations. And while we're on this board, keep in mind we said that this was 105. And if we go back to our whiteboard for a moment, 3 times a -64 is a -192. And when I add this up, I get a positive 87. When I do the subtraction, I get a -105. So in a sense, this is the proof of what we've just done. Okay, we have one more item before we go on. And this is the factor theorem. Again, we're going to have a polynomial. And we're going to say that polynomial is going to equal 0. And we're going to work it that x minus c is one of the factors, so that when we use synthetic division, this minus c becomes, in a sense, a positive c, and that would be one of the factors. All right, so let's just see what they're going to show us here. So we're going to solve this function given that it equals 0. And we're saying that given that -1 is one of the zeros. Now, we're going to use the synthetic division to do this. And we've set it up so we can go to the whiteboard here. Gives us practice at doing it again. So here, we're going to take the coefficient 15. Here we're going to take the coefficient 14, minus 3, minus 2. We're bringing this down as a straight 15. Now remember, this came from x plus 1. We're taking that one as it was x minus c. So this would have been a -1. That's where we got that from. And that would be one of the factors. So -1 times 15 is a -15. Add them up, we get a -1. -1 times a -1 is a +1. Add that up and you get a -2. -1 times -2 is a +2. So here we don't have a remainder. The remainder is 0. So then this x plus 1 is one of the factors. And then converting this to its quadratic form, 15 x squared, so it's always 1 degree less than what's here, minus 1, we don't write the 1, x squared, minus 2 would then be the other factor. So x plus 1. Now, we're going to equal each of these factors to 0. And we know then that one of the factors of this, or one of the solutions to this equation to the third degree is going to be x equals a -1. Now let's look at the whiteboard. And there they have it. Now we're not finished yet. Let's go to the next slide. This is our last slide. And let's clear it up here. So we got this. Now, what do we do here? Well, we have to factor this other trinomial. And let's do that now too. Well, it's done for us, but let's just see where it came from. So we need factors of 15. We're going to use a 3x and a 5x. And then, since it's done for us, let's use the -2 and the 1. So this is negative, this will be positive. So our outers are a -6, our inners a positive 5x. The difference is a -1x. So now we have our three factors. And now equate each of these factors to 0. And here we had this one already, -1, we said was one of the zeros. Another one will be a -1/3. And then the last one is a 2/5. And putting them in set notation, this is our solution set for this. Now, any one of these would make all of this a 0. Again, this is in another topic, but we have found the zeros. Now, for the shape of this, we're going to see it's going to cross the x-axis in these three places, relating to an earlier lesson that we've done. All right, this one was a little shorter and hopefully, based on things we've been building, understandable.